Hi, and welcome to video lesson 46A, where our goal today is to be able to determine if a relation is a function. Before you can determine if a relation is a function, you need to know what a relation is. A relation shows a relationship between any two variables, the x and the y perhaps. It can be represented in many different ways: ordered pairs, a table, a graph, and also an equation. How do you do this? How do you determine if a relation is a function? There's two tests that I'm going to be showing you in the lesson today. One's the mapping diagram, and one is the vertical line test. Let's give this a try. You'll be able to find in your notes that you have this first example here, and I'm giving you a relation. Well, typically you've heard of this as a set of ordered pairs, but now we get to call it a relation because it shows a relationship between the x values and the y values for each of the ordered pairs. You're going to see a couple new words here that you haven't seen before: domain and range. Do you see how the word domain has in it? That's the input. That's our x values. And the range, that's our y values. So what I'm going to do is make a mapping diagram, much like you saw with the birthday example that I showed you. So I'm going to take each of the x values, 0, 1, -1, 2, and -2, and I'm going to write them right here. I'm going to be sure not to repeat anything. So 0, 1, -1, 2, and -2. Okay, then I'm going to take all of the y values and I'm going to write them right here: 0, 1, 1, 4, 4. And I'm not going to repeat anything. So I'm going to write the 0. The 1 appears twice. I'll write it once in the mapping diagram. And the 4 appears twice, but I'm going to write it only once in the mapping diagram. I'm not going to repeat anything in the mapping diagram. Then I'm just going to simply connect the x to the y's for each of the ordered pairs. So 0, 0, 0 connects to 0. 1, 1, 1 connects to 1. -1, 1, -1 connects to 1. 2, 4, 2 connects to 4. And -2, 4. -2 also connects to 4. Okay, then I'm going to ask myself, is this a function? Can I tell already? Could I have these two numbers having the same output? Could I have these two numbers here having the same output? Yes, absolutely. Just like if you had two different people, they could have the same birthday. Here, these two different people could have the same birthday, right? So this, in fact, would be a function. So I want to write this right in my notes that yes, this is a function. Also, if you take a look, you'll see that there are no x values repeated. In any of these ordered pairs, no x values are being repeated. So that's a good thing. That tells us a function. So this is a mapping diagram. Now what I want to do is show you a vertical line test. So I'm going to take each one of these points and I'm going to graph it on the coordinate plane down below. So let's do that together. We have 0, 0. We have 1, 1. We have -1, 1. We've got over 2 up 4. And we got -2 up 4. So if I were to connect these points, it would actually make something that we call a parabola. Now, the vertical line test states that I could draw a vertical line anywhere on my graph and it would only go through one point. Do you see how it's only always going through one point? So here it passes the vertical line test. And if it passes the vertical line test, then yes, it is in fact a function. So what that means is that we should be able to write a function rule for this particular set of ordered pairs or relation. And if you look closely at this relation, and maybe if you put it in actually a table, you would see that the function rule is to get y, all I have to do is take x and square it. So it's not a linear function, but it is in fact a quadratic function. Okay, so yeah, I can write a function rule for it. because it's a function. Let's go over here and let's take a look at this relation. So this set of ordered pairs. Again, you're going to see those words domain, which is the x, your input, and range is your y value. So new words for us today. Okay, so now I'm going to take a look at the relation here, and I'm going to take all of the x values and I'm going to organize them right here in the domain. So that would be 4, 5, 5, and 6, but I'm not going to repeat anything when I make the mapping diagram. 4, 5, and a 6. So I write down the 3 different numbers that I see. Then the range, that looks like that's a 3, a 4, a 5, and an 8. 3, 4, 5, and 8. Okay, now I'm going to map them or connect them, just like you saw me do with the birthdays. 4 goes with 3, 5 and 4, 5 with 5, and 6 with 8. Okay, now take a look at your mapping diagram. Is this possible? Could 5 be paired with 2 different outputs? So kind of relate this with the birthdays. Could this person have 2 different birthdays? No, this is impossible. So this is going to be not a function. So I want to write that in my notes, not a function. Okay, that means there's no way that you could write a function rule for this relationship or set of ordered pairs. Okay, now I want to show you the vertical line test and how this is not going to pass the vertical line test. So you have the ordered pairs, you go ahead and graph them while I graph them. Our first one is 4, 3, so over 4 up 3. Then 5, 4, over 5 up 4. Then we got 5, 5, 5 up 5. And we got 6, 8, 6 up 8. So even if I were to connect them or not connect them, if I'm going along doing the vertical line test, that means I can draw a vertical line anywhere on the coordinate plane. It can only go through one point with each vertical line. You see how this passes here and it passes here, but right here it fails because it goes through 2 points with this one single line. So this would be a fail, and that's why also it's not a function. Now if I go back up here to the ordered pairs, before I even started, I should have been able to tell that this wasn't a function. Why? Because there's 2 x values that are repeated, and I can't have any x values repeated. So just by looking at the set of ordered pairs, when I see these 2 x values repeated, I know not a function. Okay, let's take a look at another example. So let's have you find this in your notes here. You're going to see that I have this broken up into function. We're going to look at a couple examples that are functions, and then we're going to look at a couple examples here that are not a function, just to kind of be sure we know the difference between the two. So let's focus here on function. Why is this a function? So I just want you to look at the ordered pairs, this relation or relationship here. Do you see why it's a function already? Yeah, there aren't any x values repeated, and that's good. Let's go ahead and write this in a mapping diagram. Remember, domain is the x and range is the y. 5, 3, 4, 6. And then the output here, the range, -4, -5, -3, 4. Okay, then what I'm going to simply do here is just connect the input to the output, the x to the y. So this pairs up here, 3 pairs up with -5, 4 pairs up with -3, and 6 with 4. Now, do you notice here how this is a function? For every input, there's exactly one output. And this would work. Think about if this were birthdays, right? Each person has their own birthday. So this is one example of why it's a function. There's no x values repeated. Okay, let's look at this bottom one here. Why is this a function? Well, first of all, there are no x values repeated. Could there be y values repeated? Absolutely. There just can't be any x values repeated for it to be a function. So let's go ahead and map it and see what happens. Okay, so domains are x, ranges are y. -3, -2, -1, 0. Okay. Then the y value is just the number 1, so I'm going to write it one time. Then I'm going to go ahead and connect. Remember, every single one of these x is paired with the same y. Now, is this possible to happen? Yeah, absolutely. Couldn't I have these 4 different people all have the same birthday? Yeah, absolutely. Okay, so this is another example of a function. And if I were actually to graph this, it would pass the vertical line test. So these are 2 examples of functions. Now let's go over here to not a function. Just by looking at the relation, can you tell why it's not a function? I bet you can. Do you see how we have an x value that's repeated? Absolutely. So right away, just by looking at this, I should be able to say not a function. Let's map it. You might be wondering, why do I have to map it? And the reason for that is because you have to be able to recognize and understand how to read mapping diagrams. And if you know how to make one, then you'll know how to read one. Okay, so X and Y. 1, 3, 5, 3. So 1, 3, 5. Remember, I don't repeat any numbers when I put them in the mapping diagram. And then the Y, 4, 13, 29, and 10. Okay, let's connect X with Y. 1 connects to 4, 3 connects to 13, 5 connects to 29, and 3 connects to 10. Now, do you see why this is not a function? Think about this. Could this person right here have 2 different outputs or 2 different birthdays? No. For every input, there's exactly 1 output, and this has 2 outputs, so not a function. Okay, let's go down to this one. Now, do you see how what I did here? I repeated the x values. Instead of here, I repeated the y values. So looking at this here, x and y, just by looking at the table, is this going to be a function? No, because there's x values repeated. You see all of them repeated, right? So let's just map it and see what happens. I only write the 6 once, and then for the y, I'm going to write 1, 3, -2, -4. Let's map it. So 6 pairs with 1, 6 also pairs with 3, 6 pairs with -2, and 6 pairs with -4. Now remember, for every input, there has to be exactly 1 output. And here there isn't. This input has 4 outputs. Think about it with birthdays. Could this one person have 4 different birthdays? No, that'd be pretty awesome though. They get lots of presents, but that can't happen. So these 2 are examples of not a function. And remember, we can tell that just by looking at the fact that the x's are repeated. So it's not going to pass these mapping diagrams. And it wouldn't pass the vertical line test either. Okay, last example here before we take a look at just a kind of a summary. Graphs. We haven't looked at graphs yet, just focusing on vertical line test. What makes a function? Now, if we were in class here, I would have you guys come to the board and draw examples of what would pass the vertical line test. So remember, the function would have to pass the vertical line test. So if I drew a vertical line anywhere, it could only go through it one time. So, you can get kind of creative with this. But like, for instance, if I just have just a simple line like this, that would pass the vertical line test. That's a function. I could have a parabola like this. That would be a function that would pass the vertical line test. I could have a curve like this. That would pass the vertical line test. Gosh, some of you guys get so creative when we're actually in class. I could have a line that looks like this too, and that's going to pass. So all of these would be considered functions, because if I drew a vertical line anywhere, notice what I see, I'm drawing a vertical line anywhere, it's only going through my equation, here's a linear equation. It's only going through anywhere on the graph only one time. You see how it's only going through one time? It just goes right through one time and that passes. See that? Okay, that's a function. Now, what about not a function? So this would be in the case of like if I had a line that looked like this. That's not going to be a function, because if I drew a vertical line, it would go through 3 times, and so it's going to fail there. Okay, that would not be a function. Also, if I have, boy, you guys are better at doing this in class. I'm trying to be creative here. If I have, like, let's do a curve like this. Check that out. That's going to fail the vertical line test, because obviously here I'm going to have, it's going to go through two points, right? Um, I could have actually a circle. When you guys get to geometry, you're going to learn how to graph circles. And so if I have a circle on here, clearly that's going to fail because it goes through 2 points right here. Okay. If I had a collection of points, if I were sometimes in class, I'll have people that will make some points like this, and then they'll connect them like this. And obviously this is going to fail the vertical line test, because as soon as I draw a vertical line, it's going to go through a whole, but look at all these points it's going to go through, right? That's not going to pass here either. It would pass here, but not here and here, because it's going through multiple points. All right, like I said, you guys are much better at this, of coming up with creative ideas. But pretty much I need you to understand that to be a function, it has to pass the vertical line test. To be not a function, it won't pass the vertical line test. Okay? So let's do a little review activity here, a little kind of a summary, just to be sure we've got everything. So I'm going to have two categories here, function and not a function. And again, I would be doing this in class. We'd be doing this together. So let's say that I gave you two tables and I asked you which one's a function, which one's not a function. You've got to be able to recognize by looking, when you look at a table, the x values repeating. If there's x values repeating, it's not a function. So in the case of this one right here, this table would not be a function because it has x values repeating. And so we could see, even if I put these points from the table as ordered pairs, I'm going to have the 8s repeating. Okay, here if I were to put these points from the table as ordered pairs, there would be no x values repeating. Okay, so when we're looking at a table or ordered pairs, we're looking to see, are there any x values repeating? All right. Then if I'm looking at a graph, so here's two different graphs, I'm going to be thinking mapping diagram. Which one would pass the mapping sorry, not mapping diagram, vertical line test. I'm sorry, I hope I didn't confuse you. When we're looking at this thing, vertical line test, okay, which one's going to pass? Well, obviously this one would pass, right? Because I could draw a vertical line anywhere on this graph and it's going to go through only one time. This one would not pass, because as soon as I draw a vertical line, it'll go through 2 points. Okay, so think vertical line test when you're looking at graphs. And lastly, mapping diagrams. You have to, the best thing I can tell you is think about the birthday example, right? So think, with this, see these two different people, they could have the same birthday, and that would be a function. Now, if I showed you the ordered pairs for this, 3 goes with 5, 7 goes with 5, it's okay for the y's to repeat, but we can't have any x values repeat. So this would be a function. This is not going to be a function, because do you see how these two people, the 4 and the 9, both have the same birthday? They have the same output? Not possible. Oh, I totally said that wrong. Wow, you guys, it's like 5 o'clock in the morning and I'm making a video and I can't even talk. You probably caught that mistake. 9. Do you see how 9 can't have two different birthdays, right? So this person couldn't have two different birthdays. This input can't have two different outputs. My gosh. Hopefully I didn't confuse you. Now, if I were to take this mapping diagram and write it as ordered pairs, 4 goes with 6, right? 9 goes with 6, 9 goes with 8. Do you see how the 9s repeat themselves? The x values repeat, and that's what's happening here. This person cannot have the same, cannot have two different birthdays. So that's why this is not a function. So I'm sorry. I hope that I didn't confuse you too much. But what we need to be able to do is to look at a mapping diagram and decide if they're functions or not, be able to look at a graph and decide if it's a function or not, and then be able to look at a table and decide if it is a function or not a function. So I hope that you feel that you can do that. Thank you so much for joining me for the video, and have a great day, everybody.